the back hear me? Please wave if you hear me. Okay, great. Now, in ancient history, creating software involved a lot of manual labor, such as actually typing by hand the compiler into the command line, the compiler invocation, or running tar on a bunch of compilation products to build your software, to distribute it. And more sophisticated engineers would like hand wire dependencies into a makefile. Some of us might do that still. Now, personally, I don't really like typing so much, so I work on an IDE. So IDEs do a lot of things like they offer an interface for the whole software development lifecycle, from editing, formatting, refactoring, to building, running, testing, debugging, and deploying everything at the click of a button, which is great as long as you're working on a desktop. And they give a structure for organizing code into like modules and projects. So yes, I work on an IDE, namely the IntelliJ plugin for Scala. Out of interest, who here uses that? That's many people. And who noticed that we just released a new version 2.19.1? Great. If you haven't, please check it out. By the way, did you know we're on GitHub? Like most of the sources, open source. If you didn't, please have a look, or don't. Anyway, the purchase of this talk, I didn't sleep well. The purpose of this talk is to show you an approach for integrating experiences or the interface of other tools within the IDE, namely the build server protocol. And I'll give you some specifics about the build server protocol implementation in IntelliJ. But let's take a step back. So I mentioned the IDE as like a generic front end for everything in your development process, but that doesn't really apply to all the contexts in which code is built and run, such as on the CI server or on different systems. So we have a kind of a reproliferation of special purpose tools that do one job more or less well, such as build tools, dependency managers, test frameworks. They typically have a command line interface, which is quite cross-platform and is programmable, and they will run on pretty much any machine. But when I'm using my general purpose front end, that doesn't really mesh that well. I have to switch around between contexts of CI server, of the command line, and the clicky GUI. Now we build special purpose integrations for all of these tools, but you see there's a bit of a mismatch here in styles, because every one of these tools has a bit of an idiosyncratic API and way of configuring it. And yeah, we solve this with special configuration interfaces for all of these things, like Scala test or spex2 or SPT. And in the case of the SPT integration in IntelliJ, which I have worked on a lot, we have a special plugin that has special code for mapping a SPT project to some XML file, which then gets read by IntelliJ and then again mapped to the IntelliJ project model, and that causes a lot of friction. And there's yet another SPT plugin for integrating the SPT shell, just to make it possible to run tasks and know when they're done. And that doesn't even give us very nice compiler output when you compile with the SPT shell from IntelliJ. So there's a lot of room for improvement there. Now, especially considering build tools in Scala, we regularly have new tools popping up like once a year. And Yeah, I mentioned you have a lack of coherence between the interface of the build tool and the IDE, requiring you to switch between terminal and IDE, and really I just want to use my favorite front end, just click a button or something. Now, this gives us a kind of a tangle of tools, lots of haphazard integrations where parts just sort of work together, but it's not really coherent. And I've been recently working on tying these loose threads, this tangle, together into more solid knots. So tying these threads of tooling for a more integrated developer experience. But of course, not without looking at some prior art. Maybe you've heard of the language server protocol. It's a protocol actually developed by Microsoft, originally for the Visual Studio Code editor, which allows it to integrate the editor more smoothly with all kinds of languages. So up to VS Code, most language integrations for editors or IDEs have been based on very language-specific support. So you would write in the API of the editor parsing, code highlighting, maybe refactoring for each specific language. So you have a bit of a N by M problem for every language. You want support in every editor because developers are very particular about their editors, and that creates a lot of work. The language server protocol defines a standard way of interacting between editor and compiler. Now this protocol works fine on the file and folder level, but it doesn't really know anything about the structure of a build. So the LSP protocol has been very successful, so much so that people keep asking us if we're going to support it for Scala 3 in IntelliJ. The answer is probably not, because of various technical reasons, some of which I'll go into. For instance, yeah, I mentioned the structure of the code base is not modeled, but in IntelliJ for highlighting and navigation, we need to know about the structure, which part of the code depends on which other part or on external sources. There is no common notion of building the whole build or running tests or running the application, which also makes it harder to integrate. IntelliJ's specific challenge is that it does not model the syntax tree. So in IntelliJ, we actually have our own abstract syntax tree of the code that you have in the editor. And this is the basis for most of the editing features in IntelliJ, like refactoring, renaming, formatting, pretty much everything. LSP doesn't have a concept of a syntax tree, it just has a concept of messages. So here in this line and column, there's some kind of error, and the compiler will tell you that, but refactorings and so on would, if it all, be supported by the language server. Now I mentioned new build tools popping up every year or so. One of them is Fury, for instance. John Purdy, are you here? No? Doesn't matter. I'm sure he's going to be here later. He might be working on his slides. So Fury isn't even properly released yet, but as users, if you use IntelliJ, you'd probably prefer to edit Fury projects in IntelliJ. Now, personally, I can't really justify investing the time in writing support for a specific build tool that doesn't even have a user base yet. especially since that increases the complexity and maintenance cost of the Scalar plugin. So I asked John if he might contribute Fury support, and he said no in a very friendly way. But there is still a way, but actually I'm going to show you. I have, oops. Okay. This is inconvenient. Okay. Anyway, here's Fury. I need to resize windows because they don't auto-resize. Okay, sure, why not? So I've implemented this thing called BSP, Build Server Protocol, in IntelliJ as a client, which allows me to, come on, no. This is disturbing. It moved the window, excuse me. Now, if this would resize correctly, then there we go. So this is the Fury project, which is, of course, built in the Fury build tool. And you see here, sync finished. I actually imported it into IntelliJ. And this was done without any Fury-specific support in IntelliJ. So what happened there is I did write Fury support. I did write build server support into Fury. And well, why did I do this? So there's some quote by Abraham Lincoln or whoever, give me 6 hours to fell a tree and I will spend the first 4 sharpening the axe. And I thought, yeah, give me 1 month to support a build tool and I will spend the first year developing a protocol. Yeah, that's what I did. I didn't actually develop this protocol on my own. It was initiated by the Scalar Center, if that's familiar to you. Specifically Jorge and Olaf, who worked there. And I jumped on the train because I thought this is a great way to support more tools. So this build server protocol, it extends the language server protocol, but is focused on integrating build tools and IDEs, build tools with IDEs and language servers such as Metals, which is also something that the Scala Center has been working on. And it allows you to abstract the project model into a few generic concepts, which I'm going to describe in a moment, and define some common operations with predefined semantics. So these generic concepts, they don't map perfectly onto each build tool, but they are common enough to allow a way to support most build tools most of the time. Now, like the language server protocol, the BSP is a client server protocol, sort of, in that the server side is mostly passive. The client connects to it, but it's bidirectional, so both the server and the client can send requests and notifications to each other, but typically the client is the one sending requests, which get an answer, and the server is the one sending notifications, which don't expect an answer. Now, how do I integrate a build tool with IntelliJ when I don't know anything about how to start this build tool from IntelliJ? That's one part of the protocol. Call it the discovery or connection protocol. So when you install a server on your system, it might write a file into a specifically defined place on your system, just a simple JSON file that describes how to start build server shim. And the client then reads this, starts this tool, and just communicates with the shim by standard in, standard out. So that's a very simple, generic way of connecting to a tool. This connection file might be installed in a local user-specific directory or into a project-specific directory. Now, in the protocol, we have a few requests and notifications defined just for the life cycle. So the client sends to the server, hey, I want to initialize. I want you to initialize your build. Get ready to talk to me. The server sends to the client, okay, I'm ready. And then comes the interesting stuff, and when it's done, there's a shutdown request and an exit notification. Now, the actually interesting stuff. How is a build modeled in the build server protocol? This is based largely on how Basel models built. So we have a request called workspace build targets, and a build target is just some kind of collection of sources typically that get compiled together. But a build target also contains some metadata like capabilities. Can you compile this code? Can you run this code? Can you test this code? Some language-specific data. So, for instance, in Scala, it would be the Scala SDK class path, and importantly, dependencies on other targets. Now, associated with a target, there can be any number of sources. In BSP, the sources can be associated with one target only or multiple targets. It can be files or folders. Now there's a number of actions. Here just some of the most prominent ones, like build target compile. Compile this build target or this set of build targets for me, please, server. And when you do this request, you send us along a set of build targets, and the server will hopefully start compiling and start sending the client diagnostics and progress notifications. These diagnostics, they are typically errors and warnings about specific file and folder locations. So your file xyz.scala contains an error on line 20. And then we can use that to output a number of messages or highlight them in the editor. This is pretty much the same way that LSP diagnostics work. So these notifications can technically be sent without being associated with a request, but they typically will. Also, there might be messages which are not associated with any specific file. Another nice thing are the task notifications. They get sent from the server to the client and inform the client about a running task. So, for instance, your compilation of module ABC is running and has been 20% completed. But these tasks are also associated with a request, but they might be sent independently. For instance, server task client, there's some indexing going on. Now, I want to talk about how IntelliJ Scala acts as a BSP client. This has been so far a hidden feature. It's about to be more officially released in the next weeks. And I hope I can make this work now. Let's just open the akka project, which has been exported to BSP in Bloop. Bloop is a compile server, which is developed by the Scala Center, and it's currently the only proper server implementation of the build server protocol. And I can run compile and, oh, I'm in the wrong window. Come on. And you see in this build tool window, you'll have the notification of a running build and stuff that's happening. So it counts the warnings, it gives you output of the warnings, which modules have already been compiled and where it's still working. So this gives you a nice overview of where your compile time bottlenecks are actually, which I think is an improvement on the status quo we have in SBT or built in IntelliJ compilation. Now this is not quite ready yet because we're still coordinating on the final version of the BSP protocol with the next release of Bloop and Fury. And yeah, currently this only supports Scala targets, but obviously this is easy to expand to Java builds and probably Kotlin builds and others soon. Now I mentioned there's some challenges in integrating, in mapping a project from BSP to IntelliJ. So here I'll describe some of them. So you see this nice little diagram here. We have on the top, for instance, SBT projects. They have multiple scopes, such as compile and test. And in the case of SBT, they can have any number of other scopes, but we'll just ignore those for now. And if you export this to Bloop, you need to install a special plugin for Bloop and then run the Bloop install command. This will create a Bloop setup and associate sources, targets with sources, and so on. Now, if you run this import into IntelliJ, we get into some troubles when we have shared sources between multiple targets. IntelliJ modules, namely, don't support sharing sources between modules for technical reasons, because we want to know at any point if you change this file, which dependencies should it be built against. So we do some nasty trickery. We create a synthetic module, and which contains the shared sources, and put dependencies from the proper modules onto this synthetic module. Another challenge is that IntelliJ modules only have a compile and a test scope, whereas BSP modules or targets, they might have anything, but typically they will be only one scope, so just for compilation or just for testing, compilation and running, or testing. Now, this works most of the time. This is how we do it in SBT, but in some cases it does fail. So if you have cross projects where you build the same sources against the JVM and Scala.js, for instance, then we just have to pick one in the shared module and kind of hope it is what you want at this point in time. We are working on a new project model for IntelliJ, but that might support these use cases better, but that's unfortunately in the future. So for the time being, you may have to adjust your build definition to match what IntelliJ can handle. Now, I showed you already how running a compile against a BSP server looks in IntelliJ. It gives you diagnostics and task progress in the build tool window, which is the new interface we have for showing this kind of stuff. Now that concludes the main points I wanted to make about the build server protocol. So the protocol version 2.0 is just around the corner. We're coordinating on a release. After that, the protocol should be somewhat stable, and we will be able to implement it for different servers, such as Bazel or Mill or SPT even. The implementation in IntelliJ is still kind of raw. I will work on improving this and making it more robust and able to work with all the edge cases. Now, the title of this talk mentioned build server protocol and beyond. What lies beyond the build server protocol? So if this works out, I think it might be a model for how to integrate tooling better, more effectively, because special purpose integration caused a lot of work and suffering both for users and tooling developers. And so some things we could do maybe with BSP is supporting somehow remote building or remote testing. This is especially interesting for tools such as Bazel, where you have build workers on some kind of server. There might be some special support for code formatting. Maybe this can be also done within LSP. But there's some challenges involved with this, such as some tools are pretty specific, so you have to really think about can you abstract a common protocol to work between them? And naturally the adoption, this whole BSP thing, it's not clear yet if sufficient amount of tools will adopt it to make it worthwhile to have implementations. And if you don't have sufficient amount of implementations, it's harder to convince people to adopt it when they create new tools, or for existing tools even, which may have reasonably good special purpose integrations. However, if you happen to work on tooling or are just really unsatisfied with the current state of tooling and Scala, I'd really like to talk to you and see what we can do about improving integrations, like developing a new protocol, or I'd support you, of course, in implementing BSP for an existing tool. Now, I think we still have a few minutes to talk about anything you would like to. So if you have any questions or comments, I'd be happy to hear them. Somewhere? Yes?
So this is not really a question, rather a thank you. My warmest thank you to you and all the people involved for pushing these things forward. I think pretty everyone here would agree that this is a great effort, and that it is changing the ecosystem for better. So once again, thank you, and keep up the good work.
Thank you. That's very nice to hear. Any more comments or questions? We have like 1 or 2 minutes. I already asked that one, but thank you for giving me. Okay, I guess we're pretty much ready for the next talk. So thank you, everybody.